Hello. Hey, how you doing? How's everything with the studying? Okay. When's the exam again? Is it Friday or Wednesday? It was Wednesday night. Wednesday night. Okay. Okay. Do you know what's in it? Like, what's in the exam? How many questions are there? Okay. So wait, this one it's due on Wednesday night. You said, right? Okay. Well, that should be enough time. I mean, you have today until like Wednesday. It's like like almost 3 days. Okay. It'll be good if we cover like most of the ones that are really difficult to cover. Oh yeah, I sent you like a Zoom meeting on email. Yeah. Did you get the link? Let me send it to you again. It's where is it? It's oh, here you go. It's okay. It should be this one. I'm sending it to you now, so we can like share screen. You found it? Okay. All right. So just click on that, and then I'll end this one. Did you click on it? There's only one person here in Zoom. Is what? Oh, what about like? Did you check your email? Yeah, I have Zoom. I have Zoom there. I just sent it to you. It's like here. Maybe I'll plug it in here. There you go. You can just copy that guy. Okay. And then once I see you, I'm gonna end frog. It should be the same. Oh, what's going on? Hello? Oh, here you go. Can you hear me? Hey.
Yeah, that's my computer name, the one that shows on my documents.
He's Lily. Yeah, well, that's
I
nice.
don't think someone else has sabotaged the meeting.
They call me Flipper Boy as well, But then my yeah, I just didn't put it. Okay.
I don't think someone has sabotaged
Did you
this.
wanna did you wanna share any like your screen, or did you want me to maybe
I think let's start with your screen.
Okay, let's look at the one from that I wanted to share today. Let's see. Actually, do you see this?
Yes.
Okay. Yeah, let's maybe go over this and like, did you understand the special topic stuff? Like the special topic regression?
Yeah, I'm still struggling with regression.
Yeah, it's like one of the main things. Like probably
Yeah,
like
and he told me it's gonna bring it. It's gonna bring regression.
yeah, there's like single and multi.
Yeah.
What part of it it's like that yeah, it's difficult to grasp like for regression.
And then he also said he was gonna bring another.
Okay.
Yeah.
ANOVA is the one. Do you guys have to actually know how to graph or not graph, like use it in R or just know what an ANOVA is?
And then he said that what he's gonna do, he told us to, did I give you the list of the packages he told us to install before we start the exam?
I didn't see that one. Can you send that one to me?
Yeah, I can send it to you. I send them to you.
Okay.
Yeah, this is one of them. Lockdown is one of them.
I think we already locked data.
Yeah, lock data. Yes, and then lock data.
That one we've been using that for a while. So that shouldn't be a problem.
Well, okay, well, we'll see. He wants us to. I have had this thing. I just have so many things to say, but that's my next use.
Okay. I think let's just go over like this one by one first.
Yeah, then I'll shoot you the list.
Okay. So can you see like do you like this font or is it better if I do the original one?
Yeah, that looks much better.
I'm gonna go with the original, which is
Yeah,
like
that's brighter and bigger.
this guy, this guy.
Oh yeah, that's really good.
Okay. So for the first question, do you remember doing the regressionary like you want to pull that up? The special topics?
Yeah, I have it here.
So for the first question, what is it asking you?
The first question is asking, is having a longer life related to having a happier life?
Okay.
Examine the Happy Planet Index in the log5 data package. You want to fit a model to predict happiness, including life expectancy and region. Why must you convert region to a factor before incorporating it into your model?
Okay. So that one, do you know what a factor is? Like when you do factor, like factor variable?
Well, not right
Like,
now.
so like when you look at the this is our main data frame. So Happy Planet Index, and then this is just talking about like depending on what region you are, like your level of happiness, I guess. And then like so for each of these region, you have these like there are 1 to 7, right? The thing is like when these are like numerical, but you actually want this to be like a string, like category 1, category 2. It's not you're not actually doing something with the number, right? Like when you're saying like category 1, region 1, 2, 3, 4, 5, 6, 7, right?
Yeah, those are not numbers, so those will be like strings.
So when you have like these regions and you want to get like, these regions are associated with like the country, it's easier to see the country because then it's already a string, but the region is a number. And then when you have a number, but it's supposed to act like a string, like a category, you don't want the number to be used like in a math concept, right? You don't want to be adding region 1 to happiness. You don't want to do that, right? You want region 1 to be a category, right?
Oh.
So that's why they're saying, like, what is you want to fit the model, and then why must you convert the region? The main question is why must you convert region to a factor, right? You must convert before incorporating it in the model. The reason why you do that is because it's a number. like it's a number, right? The region is a number.
Yes.
But you don't want it to act as a number. Does that one make sense? You don't want it to act like a number. You don't want it to act like a category.
Okay. Yeah.
And so I guess my answer for this is region. The region is coded 1 through 7 with an arbitrary ordering. A factor variable, which is correct, right? It's 1 through 7. And the other thing is a factor variable is converted to indicator variables for analysis. So that's what it is. An indicator analysis, a variable is kind of like, it's just saying what category it is. You're changing the 1 to 7, the factor 1 to 7, to like a category variable. So I guess in layman's terms, like every time you see like like a category that's on numerics, but it's supposed to act as if it's a string, then you want to use factor. You want to factor it.
Okay.
Because 1 to 7 is numbers, right?
Yes.
But you want it to act like a category. Like, does that make sense with acting like a category?
Yeah, because it's not technically
a number.
Number.
You're like adding 1 plus like.
Yeah, it's not
2,
like
right?
Yeah, but
it
it's
doesn't act like a number. It's like hurricane category 1 to 5.
Yeah, category. Yeah, there you go.
I mean that's like
I like that example.
That's part of the label, like example, but it works because like you're like if you're saying there's like 5 people in like region 1 and 10 people in region 2. Region 1 might as well be like country USA, and then region 2 might as well be like country China, you know?
Yeah.
But they're just saying it's region 1. They're not saying it's China or USA. But you want it to act like that though. That's why you're changing the number to a category. And in order to do that, you use factor.
Oh, okay. Okay.
Yeah.
So just like my job. So I'm in region 3 because I deal with Midwest.
Yeah. Okay. Yeah. See, there you go. If you can associate that way, that's really good.
Okay.
It's exactly that way. It's exactly what that is. Yeah. Okay. For let's look at question 2. What is this one asking?
So number 2 is asking, run the following code to fit the model, predicting happiness from region and life expectancy.
Okay.
And then we have the formula.
Okay.
Yeah.
So when you do this, it's kind of you're trying to look at this guy, right? What does the coefficient factor? What is this? The coefficient factor. Let's look at what I put right here. Oh, yes. So I would probably just run like, what does it look like? It looks like you're predicting something, right?
Yes.
When it says predict something, and how do you interpret this? Like predicting happiness from region and life expectancy. What does it look like? A regression, right?
Yeah.
Is it single or multi-regression?
That's gonna be multi-regression because it has to do with region and life expectancy simultaneously.
So it's multiple, right? So that's what I have here. I have happiness as the response variable, and then I have factored region and life expectancy as my explanatory or like predictors.
Okay.
So these two variables will affect my happiness, which is the response. And then what it's asking is like, what does the coefficient factor mean? So I kind of just did with I did the linear regression.
And
I summarized it. So when it's saying coefficients, it's actually talking about these guys.
Okay.
Right? It says coefficients there. And then when it's saying factor, it's actually talking about, do you remember talking about like the intercepts and the slopes? Do you ever talk about the intercepts and the slopes?
Yeah. This is what I'm still struggling to understand.
Okay. Which one? Which part? Which part?
Okay, so like I can see factor region 1, sorry, region 2 through 7. I don't know what happened to region 1, but
I know, like it's weird what happened to region 1.
yeah.
But like it's only asking for region 2 though, so I guess that's
Okay,
good.
so that's why. Okay, so that's how this comes into
And you
play.
see this one right
So
here?
I'll look at region 2, and then estimate standard. Okay.
So that's it. You just have to look for that number.
Okay, so that's what I look for.
Just look for that number, and that's it. And that's our answer.
Oh, okay.
Coefficient factor is asking for that one.
Okay, got it.
And you always account for the other one, right? Because it's a multi-regression.
Yeah, and so I look for life expectancy for region 2.
Like when you're saying like 0.263 units of happiness higher the world, this is you always have to account for life expectancy. You can't discount it because it's part of your linear regression.
You know, the question refuted that answer. It said it
It's wrong.
chose, it chose happier than region 1 instead of.
Let me see. Yeah, that's good that because I actually wanted the feedback if it's like the solution or not. Let me see.
Yeah. Mm.
Because like we have to explain. Let me just open that up. So what was the answer?
So the answer was, on average, region 2 is 0.263 times happier than region 1 after accounting for life expectancy.
Okay, so it's still accounting for life expectancy. That's good, but then it's saying it's happier than region 1.
Yes, it's saying happier than region 1, other than lower than the world.
Okay, I think that's obviously. I think that might be the one. Let me just look at the choices.
So in console, where do I see that?
It's in here. So when you're looking at this, just to explain what that is, it's like because region 1, in essence, I think it's gone because it's being compared to all of these.
Yeah, because you are using.
It's normalized. It's normalizing all of these guys.
Okay, got you.
So when it's normalized, it's like, oh, okay, maybe this one is higher than that's why it's not here.
Okay.
So.
But what do this line here, the at negative 1.80937, what's that line for?
The which one?
At the top, above coefficients.
This guy right here, or this?
Yeah, that one.
This guy?
Oh, it's residuals. Okay, got
That was
you.
residuals, yeah. That one is
cool.
something different. We're just talking about
Okay, then
coefficients.
we move on there.
Okay, so I'm looking at it right now. Okay, so that's what it says. So it should be the last one. Is what you're saying,
Yeah,
right?
so it was the last one. I was gonna tell you that.
Okay, what about question 3?
And then question 3, in your model, predicting happiness from life expectancy in region, which is the happiest region? Enter the number.
What did they have?
They have 1, so we got that one.
Oh, okay, that's good. And then, do you know why?
No.
Okay, so a lot of times it's like you just have to find a way to prove that you're right.
Gotcha.
Like you know how when you do these things, there's so many different ways. Like you ever heard of the term? There's so many different ways to skin a cat.
Yeah, many ways of killing a rat.
Yeah, in coding, it's like that. Like there's so many different answers, and like ways to like get to that answer. So like this is like my way. Let me just explain how I did it. So if you take a look at this, what was it? Region 1, 6.91. What is the happiest region? I thought what did I put 6.91? Group by region. Oh, that's the mean though. Oh, maybe I had to view it. Let's see. Or maybe max. Let's look at max. Here you go. This seems to make more sense. Max. So do you see what happened here? So look at the values. The number 1, region 1 is the highest one, right? This one right here?
Yes, I see it.
Okay. So like what that means is then the region 1 is the one with the maximum happiness.
Ah.
Yep. So like how you do that is using this pipe thing right here.
Okay.
So you pipe and then group by region. Yeah.
Mm-hmm.
And then like summarize.
Okay.
And that's how you get it usually. Because then what you're trying to get here is you want to know which one is the happiest region. In other words, which region has the maximum happiness.
Okay, got you.
Okay. And then like how you would like, do this is do this piping thing. You pipe it and you pipe it right here. So like, does that make sense with how you pipe it? This is like a little bit difficult. When you do it, you look at the data frame first,
Mm-hmm.
and then after that you group by, and this group by right here is like you're gonna group them by the region, right?
Right.
And then the next thing is I wanna have all of them summarized, where the max happiness is the category that I'm gonna calculate.
Okay.
And then you could do that with other min or max or whatever. Okay, so that one makes sense, right?
Oh yeah.
Okay, what about question 4?
4 is saying, based on your model predicting happiness from life expectancy and region, how much happier is region 2 compared to region 4 on average after accounting for life expectancy? Report in 2 decimal places.
So this one's a little bit more difficult because like I don't know if they want it to be a multiple or is it just a difference. What did they get?
So are we subtracting like region 2 from region 4?
Yeah, but with their answer, what was it? I thought it was. I think it's like that, but I don't know if it's a multiple. You could do it one of two ways. Either you
Because
subtract it.
the answer, I think the answer was 1.
The answer is 1.
I think so, unless I'm wrong. I could be wrong.
How did you get that one?
Yeah, I think it was 1. Let me confirm it.
Okay,
Because
let's see
this
if
was,
how we got that because that one is a little bit different.
yeah. Let me.
Why is it 1? How much happier?
Yeah, because I'm seeing 1 here on my paper.
Okay, so based on your model, how much happier is region 2 compared to region 4? So if you look at region 4, the factor is this guy. And
That's 0.76865.
yeah.
And that's 4, and then 2 is 0.263.
Is it maybe this? Let me see if this is what they did. So negative 1.76865, and maybe they divided it. It doesn't seem like it's a division because it gives you a really large number.
Yeah, it's really large.
And it's not a difference because that gives us 2. Or hold up, maybe it's like maybe it's a percentage. Like how much larger, right? It says.
Yeah.
Oh, maybe it is a percentage. Maybe you do have to. They got 1.03. Was it 1.03?
It was just 1.
They probably rounded it. It can't just be 1.
Well, but it can't be 1 because they said reporting to decimal places. Where did I get this one?
I know, like 2 decimal places. How can it be 1?
Yeah,
I think it's
something is
1.0.
right.
I think it's 1.03. It's
Wait,
probably 1.03 because then you
give me a
might.
moment. Give me a moment. Let me control
Okay.
the screen so I can go to the class and check that I can access the
Okay. Let's can you share your screen? I'm gonna stop sharing.
yeah. Let me go in there and just.
I think we can justify it's 1.03 because like.
Yeah, let's just be sure because.
Okay.
Okay, so let me go here, and then sign in.
There's probably a percent change, a percent difference. There's an equation for that one.
Yeah, I don't know.
But this question is like a little vague because it says how much happier. Okay, that can either be a difference, it could be a percentage, it could be like
that one doesn't seem right because it's not in two decimal places. So
yeah.
I got there must be something.
Did they tell you? Did they show you or tell you like what how they got the answer?
When you submit, after you finish and submit,
Yeah.
you see your marks and then you also see what you got right, what you got wrong.
Can you redo it?
The assignment, the quizzes you can redo, but the assignments, the checkpoints, once it is in, you can't change anything.
Okay, that's good to know actually. So the quizzes we can definitely redo them as many times.
Yeah, the quizzes can be redone.
And we have to focus our efforts more on the homeworks.
Yeah, and these homeworks are the ones that have 20% of the points.
What about the quizzes?
So you want me to share my screen?
Yeah, show me like how they got the answer and what it is.
Yeah, okay. So let's see. So okay, so that was
That's good. Okay, this one's a little okay. This one on okay higher than. Oh, should be happier than regional after. Okay, we got that one. Okay.
Okay, so that one.
And they said what?
Yeah, where did
okay, that's good. Your answer. Why is it red? I was just wondering why it's. Wait, it should be two then. Why is this one or two?
Well, it said it should be two. It's we said one is supposed to be two.
It should be two.
Yeah,
right?
I didn't tell you right.
Okay, so it should be a mean. It should be a mean. So like it shouldn't be the max one. So let's say mean would be.
But they didn't specify if they needed a mean or not. So
That's the harder part. Like a lot of times it's like this. So if you do mean, you get like 7.55 for mean happiness for region 2.
yeah. So I was confusing number 3 and number 4. So the 4 was the one.
Oh, 4 is correct.
Yeah, so 4 is correct. So it was number 3 that was the 2 and not the 1.
Oh man, I can't imagine. Like it was a little. I thought 4 would be wrong because like I was a little confused about that.
4 was exactly right. So I put my cursor in the wrong spot.
Let me explain number 3. So does that make sense for number 4 though?
Yeah, it's let's go back to it.
So number 4 makes sense. Why it's 2.03?
No, let's go back and do the calculation.
Okay. Let me share my thing then.
Yeah.
All right. Let me.
All right.
Okay. Do you see my screen?
Yeah.
Okay. So for the 2.03, all you had to do was if you take a look at like the linear regression, like coefficients, you just whatever they're asking you, how much happier is whatever region compared to another region. Yeah. All you have to do is look at the coefficient of that region. The larger one, because then they want how much happier that's like. How much sadder, right? So all you have to do is like divide, not divide, but take the difference. So that's what I did here. I took the difference.
Oh, so it's about the difference.
Yeah, you just subtract them from each
one
other.
And region 2.
And it has to be like a positive number.
4 minus 2, so that would be okay. So okay, now I know where to look. Okay.
Yeah.
That's what I did. Yeah. So now I'm good.
What about for the region 2 one, like number 3?
Okay, number 3 was they say region 2.
And then this is how they do it. So instead of getting the maximum number, I would just do the mean, the average. So like this is the average now. This is the mean happiness. Yeah, this is the mean happiness. Yeah.
Okay, so if you do the mean happiness, then we get the 2.
If you do the mean happiness, then if you look at these guys,
Yeah, then region 2
would be highest. Yeah,
has
would be
the
the highest
highest
one.
at 7.55.
For the most part, you should be doing the mean. And then that's why, yeah, like when I did have it for the mean, but that's why I was like, is it region 1? Because when I was looking at this, region 2 had the highest one.
Yes.
I think I meant to put region 2. Okay.
No problem. Okay, then we can go 5.
Okay, so what was 5's question?
So 5 is asking us to test if region is a significant factor as a whole. What function should you run in R on your model?
And what did they have?
And then they have Hanover.
Okay, so that's what I have.
Yeah, so we got that.
Do you know why?
No.
Okay, yeah, it's always like we need to prick that one. So, what does ANOVA give you? Like what? Like let's try to analyze that to test if region is a significant factor as a whole. What does the ANOVA algorithm? What does it give you?
I don't know. I read it, but I don't understand it.
Okay.
I mean, I read the formula, but I didn't know how to apply it.
But like, when do you ever apply an ANOVA though? I guess that's the question, the better question. When do you ever apply an ANOVA test?
Multiple linear regression.
So you know how when you remember we did a t-test?
Mm-hmm.
So ANOVA is kind of like the t-test. What did we accomplish with the t-test? The t-value versus the p-value. The p-value. Remember the t-test gives you a p-value?
Yes.
And then if it's less than 0.5, it's significant. 0.5, 0.5, 0.05, actually, 0.05 is the alpha. And then like the alpha, if your p-value from your t-test is less than your alpha, that means it's significant. If it's greater than, that means it's insignificant, right? For t-test.
Mm-hmm. Yeah. Mm-hmm.
But then let's go back and like generalize that. How many groups, how many things are being compared in a t-test? 2? Is it 2? Like, remember that week 5 assignment where you guys talked about the comparing whether there's like a tip. Remember those tips? And then also the speed, or like what was it, the 100 mph one? And then we compared for a t-test. You usually compare two groups. But then for ANOVA, you compare more than 2 groups. So like 3, 4, whatever, how many people, or like groups of things.
Mm-hmm.
But then like for the t-test, we wanted to find how significant are the differences from the mean, right? That's what the t-test says. You try to find how significant the differences between the means of like 2 categories.
Mm-hmm.
But then for ANOVA, it's a way for you to do that, but more than 2 categories. So ANOVA is a test you use to test how significant the difference are between the means of more than 2 people or 2 groups. So going back to like
mean between more than 2 groups.
Yeah, like the significant differences between the means of more than 2 groups. That's not ANOVA. If it's only 2 groups, you use a t-test.
Okay, got you. That's clear.
And then let's go back to the answer. Like it says ANOVA, but like what did the prompt ask us? It says to test if a region is a significant factor as a whole. Right? It says significant. It's a significant right here. Right?
Yes.
So since it says significant, like you need to do either a t-test or an ANOVA, right?
Mm-hmm.
And then it did have a t-test as one of the selections. So it's not factor, it's not linear regression, it's not summary, right?
Yes.
But then the reason why it's ANOVA is because take a look at the variables, the independent variables of region, the predictors. How many do you have? You have more than one, right? So you have happiness, you have life expectancy,
Expectancy.
you have footprint, all these other ones, right? GDP, population. So that's more than two, right?
Mm-hmm.
So that's why you have to use ANOVA.
Okay. All
Does
right.
that one make sense? It's just how many
Yeah.
X's do you have so that you can get region or for each region. And if you have like usually if you have a multi-regression, you use ANOVA. If you have a
Okay.
single regression, you use a t-test.
Okay.
Okay, let's look at the next one.
All right. Our next one is run a model predicting happiness from life expectancy, factor in bracket region, GDP per capita, and population. Which factors are significant at the 0.05 level?
Okay, what did they have?
So they have GDP per capita, life expectancy, region, and population.
You also had population?
Yeah, there is population. Oh, you're asking me what do they have as the answer?
Yeah.
As the answer is GDP per capita, life expectancy, region. So three of them, those three.
Okay, I think we have the same thing.
Yeah, so we have the same thing.
What do you know why?
Uh, well, it's going back to that table
Okay.
to
Well,
to see the variables,
okay.
and
Yeah.
population is not in that table.
So if you look this table, right?
Yeah.
Okay, and what is it about this table that we have to look at?
Uh,
The p-value, right?
the p-value.
Yeah. If you look at the p-value, where's the p-value? Right here. This is the p-value. Does this one make
Okay,
sense?
so that's what we look at.
Yeah. I think we did this many times. The p-value is usually the last column.
Okay.
So looking at that, and then what did it say? Which factors are significant at the 0.05 level? Right?
Yes.
So when it says significant, is it greater than or less than 0.05?
Less than 0.0, less than 0.05.
Okay, so then it gives us four things. Let's just look at the p-value there. So the first one, GDP per capita. This is the p-value. Yeah,
2.9.
and so it's pretty bad, right? It's less than 0.05, isn't it?
Yeah.
This is less than 0.05.
That's more than
You have this
0.05.
e though. You have this e guy, e to the negative
Or
zero
the
seven.
E-07.
Yeah, that means it's like really small. 2.91 e to the negative 0.7. Does that? Yeah, like I didn't actually cover this because when you have this guy, right? It's pretty small, isn't it?
Oh,
Like
okay.
2.91 times 10 to the negative 7. It's a really small number.
Okay.
This is just this guy right here.
Oh, okay, got you.
Do you know what the e to the negative 7 stands for?
No.
Okay, the 2.91, and then you have this e to the negative 7. Let me probably, it's actually better for me if I write this down. Let me just draw something out. Okay, do you see this? Okay. Yeah, it's easier for me to like just that rather than typing it. So you have this 2.91, right?
Mm-hmm.
And then you have e to the negative 0.7. So this is just scientific notation. Like what you have here is scientific notation. You have to actually convert this to a number, which is the normal standard form. So 2.91. The way you convert this is you times this by 10 to the negative 7 exponent. 10 to the negative 7.
Okay.
And then so what do you do with this 10 to the negative 7? Like to this guy. So you have 2.91, right?
Mm-hmm.
This is, I'm actually gonna need I might need more space, but the 2.91, when you have an times this to a 10 to the negative 7, you have to move this decimal 7 times. 1, 2, 3, 4, 5, 6, 7.
Right.
1,
Okay.
2, 3, 4, 5, 6. So this is the value actually.
Okay.
0.000000291. That's the value.
Oh.
Yeah?
Yeah, I get it now.
Okay. So you have to do that every time you see an E.
Anytime I see the E.
Yeah. And then
Okay.
like if it's like a negative value, if it's a negative value, then you move it to the left.
Okay.
Okay, so let me see. Okay, so that's that guy, that's this guy. So is that less than 0.05?
Yes.
Okay, so that's why we have that. And let's look at the next one, life expectancy. So you look at this guy. So this guy, is this less than 0.05?
Yes.
Okay, this one's an easy one. So we
Yes.
check that. What about region? So
Uh,
there's a lot of them, right?
yeah, we have a lot of regions.
So it's like pretty much all these guys right here. I'm just gonna highlight.
So pretty much the only one that is more than 0.05 is population.
You got it. Yep, you got it. Yeah, that's a
Now,
good
now,
one. Yeah,
now I know how
that
to.
means that one isn't significant.
Okay.
Yeah, this one's an easy one. You just have to like put summary and linear regression. It gives you the p-value. After you get the p-value, which one is less than 0.05, and that's it. And then another way, if you didn't want to like do the math for that, you see like these asterisks. You see these asterisks.
Mm-hmm.
Look at this guy down here. So if you have like triple asterisk, it's less than 0. If you have like 1 asterisk, it's less than 0.01. And then if it's this guy, 2 asterisks, it's less than 0.01. Or like, let me say 0.03. Yeah, and that's a way. Like, if you have an asterisk root, for the most part, you're gonna be you're gonna be significant. Because this guy doesn't have an asterisk, right?
No, it doesn't.
Yeah, so if you have an asterisk, that means you're significant.
And you say 2 asterisks, so it's less than what?
I'm trying to look at it right now. It's so 0.07. It's actually greater than. So, but then there's 0 right here. The 0 right here is obvious. This one is, let me see, 0. Okay, so the asterisk is actually, if you have the asterisk here, it's you're between 0 and then this guy.
Or between 0, okay, between 0 and
Yeah, and if you have like 2 asterisks, you're between 0.01 and then 0.001 and 0.01. And then when you have the, 1 asterisk between 0.01 and 0.05. Does that make sense? This is how you read this guy. I know it's a little cryptic, but then that's just how it is.
Okay.
All right, let's take a look at question 7.
Okay, 7, fit a model to predict happiness from region and life expectancy that also includes the interaction terms. If the interaction term is significant, what does that mean in context?
Okay, so what did they have actually first?
So they have the slope of the linear relationship between life expectancy and happiness differs based on the region.
So that's what we have, right?
Yeah.
Okay, do you know why?
No, because I don't understand the slope.
Okay, so when you have this interaction, what they're talking about, let's just run the code here first. So the code right here is gonna show us this guy. So what I did there, when you do interaction, what does interaction kind of like, when someone tells you interaction, what does that kind of mean? Like
It
they have
means
to,
there is a relationship.
and in mathematical terms, you just times those guys, right?
Yeah.
So you do the same linear regression, but then now they want you to do it for region, life expectancy, region, life expectancy, and then region times life expectancy. And then when I run that, I get this guy right here. Yeah.
Okay.
And then so it's not really significant. It's just they're just saying if the interaction is significant. It's not though, right? It's like greater than.
Okay, so I look at 0.175,
Yeah.
which is greater than 0.05.
Yeah. And then this is just a definition. When they're saying if the interaction term is significant, it's usually talking about the slope. Like it's talking about this guy right here. This is the slope of the interaction.
Oh, that's the slope.
That's the slope, yeah. The negative 0.007884. And then when it's saying if there's a because when it's like there's a significance, you usually look at the slope of the interaction. You don't look at the intercept because it doesn't tell you anything, right?
Okay.
The slope is the coefficient that you look at when something is significant. So that's the reason why. You don't look at the y-intercept, and you don't look at if they're nonlinear.
Wow. You see, this is gonna be tricky for me because I won't know
Yeah,
that
when they're
this is
saying
where.
like if there's an interaction, the one thing is you look at the slope. If there's an interaction, like all the answers, they don't talk about slope except for one, right?
Oh, okay.
None of them talk about none of them talk about the slope except for this guy in the second one.
Okay.
And that's just what you have to remember. If they're talking about interaction terms, you just have to say you look for the slope. It's like, oh, okay, this might be the one.
Okay, got you.
It's just clues to make it easy for you. Okay.
All right. So that's good. So
What
now I
about
get
question
that
8?
one. Number 8 is saying uh, fit a model to predict happiness from region and life expectancy that also includes the interaction terms.
Okay,
So
what did
what
they get?
all that apply?
Which one did they get?
So it was region and life expectancy.
Oh, it's both of them?
Yeah.
Why is it both of them? Let me see.
Yeah, someone asked that too. Someone was asking why did they include region?
Why would you include it? We ran the analyses, right? What did the teacher say? What did it,
The teacher
yeah,
the
what did he
teacher
say?
was saying the teacher didn't I didn't get a real answer that he said it,
Okay.
but yeah, but someone asked it in the chat.
It's a weird one because like if you look at this and when you're saying you're talking about like if something is maybe you know why? Because since if life expectancy, because there's an interaction. But the thing is, what about this interaction?
But where's the interaction in the console?
The interaction is this guy right here.
Ah.
But the interaction itself is like greater than 0.05 though. Right?
Yeah.
It's greater than. So if it's greater than, like, it can't be significant. Like, and then region itself right here is greater than 0.05.
Let me ask you, what does this thing here mean? You know, if you look under the negative 0.007884, what does this thing stand for?
Which one?
You look at that line, the
This guy?
interaction line.
The interaction line?
Yeah.
Okay.
Yeah. So this other one, the one that is 0.007884, what is this? What is this for?
This right here is the slope. This number. This number?
Okay. Okay, so this is the slope, but the 0.175 is the
p-value.
The t value.
It's the p-value. This is the t-value.
The p-value.
Yeah, this guy is the p-value on the right. This guy.
Okay, gotcha. I was getting confused.
But the thing is, like, why is this region? Maybe it's probably because it seems like it's not right though. I don't know why it would be.
Yeah. A guy asked that question. One of my classmates asked him in the chat, but I haven't seen the answer to that question from him.
And then, like, if you look at it, does it explain anything why it's a region as well?
No, there was nothing. It was just the answer.
Okay. Well, I think you just accept it. It's hard to explain because then, like, I'm looking at this right now, right? Fit a model to predict happiness from region and life expectancy. Region plus life expectancy, that also includes the interaction. What if we take out the interaction? It says include the interaction. That's why I included that one. If you don't include it, you see this right here? I didn't include it. If you don't include the interaction terms, then it's significant. If you include it, it's only life expectancy that's less than 0.05.
So then they were wrong.
It seems that way, but then if that's the case, I need to know the answer. Like, what did the teacher say?
Well, if I'll go back to the chat tomorrow and then I see if he has answered that question.
Yeah, and ask them why or how they got it. I mean, why and how.
How he got there.
Because then at least we know, moving forward, like, before the exam ends. Okay. All right. What about number 9?
Number 9, we are being asked random model predicting happiness from life expectancy, factor in bracket region, GDP per capita, population, and the interaction of life expectancy and GDP per capita. The code is below, and then the code is there. So and then they say which variables are in the final model.
And then what did they put?
And they put life expectancy, and GDP per capita, and like the second one, and then region.
And region, okay.
Yeah, so
there's
it was
3, right? There's 3.
Yeah, so it was life expectancy that you got right there.
But it's one more. It's life expectancy, the other one, and then the region.
No, it's life expectancy, and then the line where you have life expectancy colon GDP per capita.
Yeah.
It was included in the answer, and then the region.
So how many?
So 3. The only thing that was not ticked was the lone GDP per capita.
Okay. So let's try to explain that one. So it's actually 3 of them.
Yeah, 3 of them.
The life expectancy, and then life expectancy interaction with GDP per capita.
Yes.
In the region.
Correct.
So let's look at like the output, because then this is how you do it, step EAC. And then so, you know, when you do this, you have to look at this guy, like the output, and see if you can conclude something. So you have life expectancy, GDP, not GDP, region. And then also the GDP is this guy. Okay. This is this value. You have to take a look at okay, let me see. So not that one. Okay, the GDP. Life expectancy factor. Not that guy. And they don't even give you like the actual code for this as well.
You're asking if they give us one?
The code. They just tell you the answer, is what I'm saying.
Yeah, they gave us the code is the one you already put there, which they said the code is below, but they didn't tell us any other stuff.
Yeah.
They just asked which variable is in the final model.
Okay, so if you look at this, then you have this guy, and then you have this one is the value, -148. And then you have also, so we're trying to justify why the GDP per capita is not part of it. That's the only one that's not part of it. GDP per capita. Actually, if you take a look at these guys, yeah, I think that might be right. Because if you read these guys right here, right? Like all the way to the start, there's 3 things happening here, right? There's let me just enlarge this guy. There you go. There's 3 things, right? Are like step. So this start one, and then you have this guy. And then take a look at like these ones. So you see this population, right? Then there's life expectancy GDP. And there's a region, right? And then this one has like life expectancy GDP again, interaction, and then region, right? But it doesn't have GDP per capita. And it's asking you, the main question here is which variables are in the final model? Yeah. So you don't have GDP per capita, but you have like the region, life expectancy GDP, and it's a similar question of the previous one, why you include the life expectancy.
I don't see region. Where's region?
Region's right here. Region's right here.
Oh.
Yeah, like region is region, right?
Okay.
We just factored it, but because I think that's what they want you to do. The life expectancy factor region plus population. Let me see. Actually, did they put population in there? Yeah, I did. Life expectancy factor, GDP, population.
Yeah, they put it.
Life factor, GDP, population. This guy. Okay, that's good. But yeah, I can justify that region is part of it because it shows up in the final model. These are the models. You start it, right? And then the step, for both of these, when you have both of these guys, you just take a look at what are the variables that are right here included. You have population that's included, but that's not part of the answer. You have life expectancy and GDP, and you have region. And then, but you technically have life expectancy because you have the interaction. But then what? It doesn't have GDP per capita, which is like a little weird. All you have to do is assess like what are the variables you have here.
Well, but I'm seeing population there, so how will I know that I shouldn't choose it?
Because it's not in there. It's not it.
Or because it's not in the it's not in the choices. Okay, I see what you're saying. All right.
Yeah, which variables are in the model?
Okay. Then number 10 is asking, what does overfitting mean?
This one's an easy one. Yeah, do you know what that means? It's like it's just a definition.
Yeah, it's a definition. When a model so closely follows the data on which it was trained, it doesn't generalize well to predict future unknown samples.
What do they have?
That's what they got.
Okay. I guess, okay, did you guys cover overfitting? There's kind of a lot of definitions for overfitting, but the one thing is when you overfit something, it's like you're training. It's like a machine learning. I don't know if you guys touch on machine learning, but
no, we haven't done it.
Okay, but I'll just tell you, like when you overfit like your model, what that means is you're adding too much training samples, so that you're not able to predict the right test value. And when you're saying test, that means that's the future value. So if you look at like the choices you have, look at the first one. The predictions are always overestimating the true values. That's definitely wrong. Like because it's not talking about training or future or test value. When you see overfitting, you always want to look for these things: training or tests. Training or tests.
Okay.
So if you don't have those, it's not the right definition. So if you have, for example, look at B. Our model predicts the test set extremely well, but fails on the training set. That can be right as test and training, but the thing is, training set, when you're overfitting, you're actually not predicting the test correctly. That's the other definition.
Okay, you're not predicting the test, right?
You're not predicting the test. But then this one tells you our model predicts the test set extremely well. So that's definitely wrong. That's not the right definition. So let's take a look at D. Our model fits the data so well, it is nearly flawless in prediction of.
Wait a minute. Let me take that back. Why do I have?
Which one?
Hold on. I take that part back. There is,
Huh?
I think. Let me take that back. Hold on.
Okay.
Give me the screen again.
You want to share your screen?
Yeah.
Okay.
All right. Let me. Yeah, we got it. Yeah, that was it.
Okay, that's good. But like if you look at the D one, the reason why it's not D is because it says our model fits the data so well. It's not that too. Like overfitting is a problem. It's not a good thing.
Okay.
So that's why when you read C, our model is so closely follows the data on which it trained, it doesn't generalize well to predict future unknown samples, which means that's the correct one because it seems like it's a problem.
Okay. Predict future.
Yeah. So you're using so much training values, it fails to predict future test values. That's the generality of overfitting.
Oh, okay.
Okay, so that's done. What about, do you want to cover chapter 1 to 5 or 7
Yeah, yeah, we can cover chapter 1 to 5.
Okay. Do you wanna you have those files, right? Maybe we can go over the answers. Like what, you have the solutions for those?
Yeah, I got them. I can open them up too.
Okay, if you can share them, and we can just go over like the ones that seem blurry.
Yeah, chapter 1. Let's see.
Because like if we go over them one by one, it's gonna take a lifetime.
Okay.
I just want to like look at them and then maybe like actually we still have tomorrow and then we still have Wednesday.
Yeah.
So we'll go over that and see. I want to gauge which ones maybe I have to focus on. Maybe do a code for it, or like maybe give an example. Okay.
You have my screen?
Yeah. Can you share your screen?
Yeah. Okay.
I'm gonna I'll leave this. Okay. Whichever chapter. I guess we can go with 1. Is this number 1?
Yeah, this is number 1.
What is 1? Intro to R. Okay, let's take a look at it. Oh, you got a good score. That's good.
I really.
I mean, like, let's look at. I haven't actually taken a look at this. It's like, so what is the output? This is just doing math. Okay, so you got this one. This is good.
Right.
Okay, and then question. There's no question on this one, obviously, right?
Yeah. This one. Yeah, this one was easy.
It always starts out that way, yeah.
Yeah, this one was easy.
What data would you prefer to store? Data frame, obviously.
Yeah, so we can skip that one. Then let's go to 2.
All right, let's look at this one.
And then 2 TD. Yeah, the TD thing almost drove me crazy. I didn't even understand this thing, no matter what you told me.
I think you have it.
It took me years to learn
it. Well, you have 5 out of 5, which is good.
Yeah.
Which of the? Oh yeah, you could repeat the quizzes, right? You said.
Right.
Yeah.
What is proper way
to load the package called 538?
Okay. Oh, yeah. By the way, that 538.
Yeah.
It's one of the things that we will have to download.
Load in. You have to load that guy.
Yeah.
You just have to do it. You know it already. I mean, you just load it. Library 538. Well. You have to use it somehow, obviously, but loading
because what it told us is that we can download those packages, but then the question might be like,
which verbs are required?
Oh, okay, yeah, like you gotta do some analysis. So if I don't understand the output, I may not give him an answer.
Yeah. For the exam, I don't know if you can, like, we have to go through the, I guess, the nitty-gritty, the tidyverse nitty-gritty, like how to actually use it. Yeah, that kind of, because tidyverse is coming. He said that. And then 538.
Yeah, 538 tidyverse.
That's just a data frame. I think that's just a data frame.
Yeah, and
man, you got all this correct. This is good.
Log file data, and there's another one.
Okay.
Okay, so this one we can leave it alone.
It says that you should use group by. So you could. Did you use group by for this one, number 6?
I did it, but if you ask me today, because some of these things I had to go to Google, YouTube, so it wasn't like I knew them.
It wasn't like instant, yeah.
Yeah. So like, if you pin me down now, you may not.
You have a lot. The thing is, you have a lot of time for the exam, so I think you should go over the exam, open it today, and then like look at it.
I'm already nervous.
Huh?
I'm already nervous.
Okay.
I don't know why. I am so nervous.
Nah, you shouldn't be. Like, it's you have like good scores. I don't know why you're nervous.
You have
good scores.
When I have had enough time and read, I'm always very confident about myself.
Yeah, so, good.
Yeah,
so you always do that one, yeah.
Yeah, if I'm not like this time, that's why I'm having the butterflies.
Okay, how should one type standard? Don't overthink this one. Just type in the body of the document. That's so funny. Why is it representative research? Okay, yeah. For these ones, I probably think, like, I don't know if the questions will be the same. Maybe you could like look back at these guys and then like compare the answers if the questions are the same. Yeah, I think I'm gonna do that because I printed them. I printed the questions, so I think I can go back in here and check the questions on my papers. And then that's what I usually do. Is the exam kind of like this format? Question 4 like this, exactly like this? Yeah, he told us that the questions are going to be like the quiz. We will not do like crazy calculations. He told us not to think that way. Okay. But we should think like, he will ask like, this is this, then you choose like the ones we just did.
like the ones on that question one, the one I just closed.
Yeah.
And then on top of that, he will put stuff in the package and then output it,
Yeah.
and then you will analyze.
Oh, I see. You don't have to actually use R, but he'll give you the output.
Yeah, he will give us the output.
That makes sense. Yeah. I mean, that's fine. I think that's better that way. It's more like applying it rather than the coding.
Yeah, jump scared.
Nah, it's fine. You're totally fine. like, like I said, if you already opened it. If there's something there you think that's difficult, let me know, or like let me know what it is. Like what type of question is it? You know.
Yeah. Okay.
All right. Let's take a look at the next one.
Yeah. So let's go to the next one.
Okay.
Okay. This is that's not the one. Okay.
Week 2. What week are you on right now?
Right now we are in week 8 today.
That's the final exam.
Yeah, the exam was supposed to have been done yesterday.
Oh, really?
Saturday and yesterday, but then he changed it because we had assignments that were being turned in yesterday.
You don't want to, yeah, he should change it. You don't want to be doing assignments and doing the exam.
And doing the exam. So people asking, why are we turning in 4 assignments and doing
No
exams?
way, yeah. That'll be crazy.
The same weekend. Okay. So he said, fine, change it in.
That's a good idea. Okay, let's take a look at this one.
Okay, so this one, I think this is where my problems began.
This is the statistics stuff.
Yeah,
the statistics come in here.
Yeah.
Can you give me like 1 minute?
Pardon me?
Can you give me 1 minute? I'll be back after this.
Oh, sure, absolutely.
All right, I'm back. All right, let's look at this. What's question 1?
Okay, so our question 1 was
okay, 5 out of 5. That's awesome.
That was question 1 was
a data set contains a variable revenue. There contains the daily. What type of data is this? Yeah, it's numeric. It's either numeric or categorical.
Yeah.
Logical is also true or false, but then it's numeric. Yeah. Okay. This one makes sense,
this
right?
one makes perfect sense. Now here is where I really struggled.
All right, I see. So maybe you do have to like run it here. Obviously, he won't give you the output, but this one you have to. It is a quiz. So the very first thing is, let me read it first. We look at a computer data set used to help to learn. Okay, what is the mean price for the computers in the mean? It's asking for mean, right? So first of all, how did you get the answer?
YouTube, Google.
Okay, I see. So let's look at this guy, the install.packages. The very first thing, if it gives you something like that for the exam, you just mentioned to me that they give you the output, right? So you probably don't need to do this, but for me, I would still confirm it.
But still, I would like to know this thing. So what are we gonna do? Even though I'm gonna sit for my exams on Wednesday,
you're gonna continue, obviously.
We will still meet so we can go over my weaknesses.
Yeah, no, that's what I'm
That
saying.
way,
Do you have another class like this class? Like,
yeah,
is it
you
done?
will take me. I'm taking data management. So I know it still continue until December, but I'm gonna have to have you take me like just for tutorial, no homework, so we can go over things like this, so I can.
For R, yeah.
Yeah, for
The hardest part to learn is just definitely, like the coding. The coding is the hardest part.
yeah, because I'm not good at coding. So if you give me tutorials on coding and so I can get grounded,
You will.
then I
Like,
have the
no,
skills. Because right now I've just been kind of like trying to catch up with homework, but
which is like a lot of things.
with a
Like,
lot of things because
you haven't really focused your mind in learning just the code,
that's the
right?
point. So we're still gonna do some extra lessons just so you
Yes, that's actually that's the best thing I feel like we should do is because
yeah.
when you do the class, obviously you want to pass the class. That's like priority. But then the next thing is why don't we focus on like how in the beginning we talked about like the how to do the loop.
Mm-hmm.
We could do that with like each of the
Yeah,
packages.
those things you're gonna take me to teach me the loop. We're gonna go over loops. We're gonna go over conditions. Those
Yeah,
kinds of things. That way,
conditions, and then
yeah,
the what else is there? The classes, the functions. Functions are great. And then like I'll take you to like maybe each one of these guys, like the statistics package, the tidyverse
yes,
package,
yes,
all of them have functions that is very beneficial.
yeah,
And then I think like learning just like different ways that you can put
yeah.
things
Because I
together.
didn't give you the because I was very behind. I didn't give you the chance to.
I know, no worries. And then what is after this class though? Like after this class, what do you have to take?
Data management.
Is that with R as well?
I'm just thinking.
I'm pretty sure yeah, you're gonna be data. So this class was business analytics.
Yeah,
So
this was data analysis and statistics, but the program is data analytics. Yes.
and data management, it seems like you will use. I feel like you're gonna be using another program as well because it's management. Maybe like something related to like SQL or something. But we'll think about that later. Okay, let's just take a look at this first. Question number 2.
Okay. So
So, do you have your R open right now, or maybe like try to copy what they have right here, and then I'll guide you to how you get the answer.
okay.
So like all probably just copy like the code part. I think the install packet, yeah, that one. The 2 lines. Not that one, the other one, the next line. That guy, yeah. And then the library that. And then the next line over.
Oh, there's these two.
The install that packages and library that, yeah. Both of those. Just those two, yeah. Those are the code ones. And just go to R or wherever you have R, yeah. Okay.
Yeah, let me see.
Man, like if I wanted to, I don't know if you're interested, but later on, like because you're learning R right now, but actually they use like Python in the real world.
Oh, you can teach me that one too. December will be doing nothing.
Because like Python is the one that I teach a lot of Python, which is like the same as R but easier. It's
Yeah, you
actually
can teach me that.
it's
You can.
actually easier than R. But then
Oh,
like a lot
really?
of people they use they use either R or Python. But with Python, I'll let you decide, but which one you like. But I have a lot of lessons for that one.
No, I would like to check that one
Did
because I
you
think I
did
think
you
JP Morgan uses Python.
you get JP Morgan use JP? Oh, okay, Chase, right?
Yeah, yeah, Chase.
That's my bank actually.
Yeah,
So,
actually, I used to work with them, and
so they use Python? That's really interesting. I didn't know that.
yeah, I think so. I'll ask my former colleague because I'm working for Morgan Stanley, but I want to go back to Chase once I finish this program.
Okay. Yeah, that's actually really good. That side, I don't know about the business analytics, but I know it's been around for a while, you know.
Oh, okay.
Like they use business analytics for data science kind of work, and then they do like what R, and then I think Jupyter Notebook with Python. That's something. Yeah. Wow, this is taking a while.
That ad is taking forever. Okay, here
Okay.
we go.
Okay.
Finally.
All right.
Mm.
Let's open up a script. Okay. Ah,
Where did you go?
I thought you have aces. You have aces, right?
Yeah, this is Aces.
It should be super quick. I don't know.
What happened?
Try open up a script. Try new script. There you go. There you go. It's right there. You could just paste it again. Okay.
Finally.
Try running those two. All right. Okay. So it installs it. I don't know if it has to load anything. I think it is because it doesn't have a caret, so I think it's loading. So after this is done, you have to look at the computer data frame, I think. The data set. Oh man. Oh, there you go. You have to click on that one. Install. You see that says not installed?
Yeah.
Or is it already doing it? Sometimes I have to click on that. Okay. Unpack and okay. Try click on the install. Yeah, click on that one.
Okay.
Because sometimes you have to install it. It's like a lot. So install it and then actually type install and then the library.
Yeah, the teacher installed a lot of things.
Okay. Okay, there you go. That's that. That's the one I was wanting to say. Oh, this is a big like file, huh?
Takes forever.
Do you have is your ASUS, is it like solid state or hard drive?
Well, if you ask me in technical terms, I won't answer the question.
I think you like when you bought it, what was it? Like is it 1 terabyte? Or like the storage?
I
Maybe-
don't really remember because I've always been using HP. So normally I go for the 8.
Okay. So
Yeah.
the Asus, because I have an Asus, but that one has like he has like a double drive. Like usually
I think that's what I'm gonna get.
yeah, you should get a double drive one. The reason why is like
Yeah.
it's faster. It's faster.
Yeah, because this thing is too slow.
It's all good though.
Yeah.
I know. In terms of because you want to be
And I
doing
didn't know much about it, so I didn't want to spend a lot of money. And then I come home and then something happens. I don't like it.
yeah. No, but that's my biggest suggestion is like when you want to be doing data analytics, you could just go to Best Buy and probably tell them, oh, can you show me a solid state Asus?
Solid state Asus.
Yeah, and they're definitely they'll know exactly what that means. Like, oh, you want solid state? Okay, it's more expensive though. That's the thing.
Yeah, but that's okay because if it's gonna run well for my,
it's faster. It's
yeah.
definitely faster, and then it's better for this kind of work, like the analytics.
Yeah, that's
what happened though. What is going on here? It says error.
Yeah, I'm gonna
Failed
buy
to
it.
look directory for modifying. Try removing. Why is it doing that? Let me try running. Let me try running. Let me try running it in mine. Install. Okay. Usually there's no error when you install these things. Ec that. Okay. Okay, I'm running it. Let me see what's going on.
Okay. You want me to stop sharing?
Oh, it's fine. I want to see if I can emulate. Okay. If I get the same error.
All right, cool.
Okay, so it's loading. Okay, good. And okay, it's done now.
Okay, so stop sharing.
So try redoing it again. Try running it again, like the
okay.
Yeah. I want to see if we get the same output. Yes.
One more packages. Okay, that we have solid state. You put that there.
Yeah, solid state. That's the. You could even ask them. It's more expensive, but it's worth it. A double hard drive. There's one with a hard drive and then one with a solid state drive.
So this solid state is better than double hard drive.
So I'll say it like this. So solid state is it makes it so that your computer, when you're using that as your main hard drive, main drive, it doesn't have to load so many things. It's much quicker. But if you're using a hard drive as your main drive, it's much slower. It's always much slower. That's just what it is.
Okay.
But the thing is, with the solid state drive, it's fast, but then you don't have that much storage like a hard drive.
Oh, it's little?
Yeah, it's little, yeah. That's the thing that you're gonna see, like, oh, why is it only 128 gigs or 256? It's because that it's expensive per gig, per byte. For nowadays though, I think you can get like a 1 terabyte, solid state drive for like maybe, I don't know, like $2,000, maybe something like that.
Okay.
But you obviously don't need to buy that. Like for solid state, you just have to buy maybe like 500 gig or 250. That's good enough.
Yeah, 500.
Because you probably have like an external hard drive, right?
Yeah, I do.
Yeah. All you need to do is hook up the solid state computer to our external hard drive, and you don't need storage because you have an external hard drive.
Okay.
So you could just buy the smallest one, 128.
Okay, the 128.
If you buy the 128, I think you can just buy that for like $500.
Okay. I'll go to Best Buy. It's right around the corner.
Yeah. Let's see. Why is it still doing this?
It's still restarting our session. For how long?
Oh my goodness.
Well, let's move to another question. We will come back to it.
Try go to another console, yeah. All right.
Yeah, let's go to another one. Because R can take 10 years to load up.
And I've had that issue. I'm very impatient type of person as well. That's why I switched to the solid state like right away when I found out.
Yeah, I can't deal with that. I cannot deal with that.
It's like, because like if things are much faster when you're like analyzing, you can do more, right? Like if it's faster, you can do more. If you have to wait, that's like the worst thing for your business.
Yeah, until I can even lose track of what I'm doing. Okay, I'm gonna stop sharing.
Let's just go back to the quiz one. We could probably just move on. Let's look at to the quiz. I'll just explain it.
Okay. So where is the quiz? Now I can't even find the quiz.
Okay.
Wait a minute. What happened? I think I tore it.
Okay, let's try to cover like 2 to 3 and maybe 4 to 5 tomorrow. I don't know what chapter we're on right now. Are we in chapter 2?
We were on 2.
Okay, that's good. That's a good pace. So 2 and then 3, and then we'll cover 4 and 5.
And then tomorrow. We can cover 4, 5 tomorrow.
Yeah. And then like in terms of the coding, maybe I'll run through like a coding thing.
Okay.
And kind of just explain tidyverse, and then all the other stuff, statistics.
Yeah.
Okay. Did you find the website or the quizzes?
Yeah, it's coming up.
Try to like, a lot of times when things are going slow, it's because of there's a lot of windows open. Try the R windows, you have to try closing them. Yeah, I think that might be why it's going slow. Are you there? Hello? Oh no. What happened? Hello? Hmm. Hmm. What is going on? Hello? Can you hear me? Something happened, yeah? Yeah, I've been having like weird things happening today. Can you hear me?
Yeah, I can hear you. I lost you.
I emailed you. I was like, oh, what happened?
Yeah, I don't know what happened. And
Was it on your end? Did it kick you or I was still here?
I think it was on my end because all of a sudden I couldn't hear you anymore.
Okay.
But I think it was on my end.
I thought at first you exited, you X'd out the windows and Zoom was one of them.
One of those things. And I was like, then I was like, I could hear you talk. And I'm like, then it's.
Okay, good. Okay. Yeah, were you able to find the quiz or yeah, the quizzes?
Yeah.
Yeah, I think it's all these windows. It's like usually I don't know if each one runs really. Yeah, there's like yeah.
What happened to the quiz? I opened it. What happened to it?
I think go back to your Google Chrome. Google Chrome. Oh yeah, you can just go there. Yeah. All right. Okay, that's good. I guess that was pretty fast. I think it was just something with the windows. There was a lot of windows opening.
Yeah, something went amiss with my
Yeah.
stuff. Okay, so we went week 2, and we will go to material number 2.
Okay. I think we were on this one.
Yeah.
Did you watch these videos? They're pretty interesting actually. They teach you like how to do R. It's a plotting right there.
I don't even remember. I was very busy
I see.
in Google and YouTube.
Okay, I think this is the one. This is one of them. Okay, look. This is a good vision. This is just a concept one.
Mm-hmm.
This question 2. Making a pie chart, you should pass a vector of values to the pi function. To clarify this is what I'm referring to. Okay. Yeah, I think this is false, I think. Yeah. Okay, and this one, the parity chart is a bar chart in which the bars are in what order? Yeah, this one, just know the definition for sure. And which of the slow it's ordered by carry, assuming that which of the find commands will get me a side by side. This one, I would just run this again. If they ask you something like this, I would run it. And you know what skewed left, skewed right is?
I just know it's like when I have a chart.
Like it's usually the long tail, like wherever the tail is.
The
that's
long
where
tail on the right and then the long tail on the left.
Yeah, the long tail. Yeah, not the hump. It's the long tail. Okay.
Okay, let's go to. I think 2, 3 was pretty straightforward.
3.
If I'm that one I know it was.
Oh, week 2 and part 3.
Week 2 part 3 was, I think, was the easiest assignment I had.
Let me see.
Yeah, the rest was just something else.
Grammar of graphics. This is ggplot. Yeah. Grammar of graphics ggplot.
Yeah, ggplot.
All right, ggplot is pretty easy. It's just doing the. Let me see the questions. In the grammar of graphics, GG, which of these layers is required to make a meaningful graph? Aesthetics, yeah, AEC. We've done this one. If you have loaded tidyverse upon starting your R session, you do not need to load ggplot2 separately to use it. True, yeah. Yep. Make a traditional scatter plot. What is the correct geom? Oh, we talked about this one when we were doing data count. When you're doing a scatter plot, it's just geom point, right?
Yeah, geom point.
And when you're doing histogram, it's geom histogram. And then what is the name of the aesthetics that controls the transparency of the points or bars? Yeah, it's alpha, yeah. We also talked about these small ones. That if it's the, was it AEX? Yeah. Make a traditional scatter plot. What is it correct? Yeah. Oh, okay. We got that one already. Let's go to 5. So for 5, what's wrong with this code? Yeah, you know, the pipe shouldn't be used when the ggplot statements. It should be a plus. Let me see. Pipe shouldn't be used with the ggplot statements. Oh yeah, you're not gonna be using a pipe for ggplot. Remember we did this one. You have to always add them. Yeah. So when it says pipe, it's that thing right there, right?
Yeah, this stuff right here.
Yeah. So yeah, ggplot, you always have to be adding them if they have to ask you this. And then this is plotting a histogram because it's a geom histogram, right?
Yeah.
Okay, next one.
So week 3.
Yep, the third one. What is the third one really?
Yeah, that is where like what
Week 1 was like intro. Week 2 is like statistics. What is that? The linear regression one or something different? Oh no, linear regression is later on.
Yeah, this is when you start describing data.
Okay.
Data types, discrete data tables, measures of center.
You know what the measure of center is? That's the mean and
No.
median and the mode.
Oh, the mean, the average, the mode, the median. Oh, this one's the easy.
Yeah, typically when you're saying measure of center, it's usually just the mean.
Yeah.
But sometimes you have to look at the median if it's skewed. And then measure of spread, which one is that? That's the sigma, right? Standard deviation.
Variance is what
Variance is the same as standard deviation. It's like the square of it. So the standard deviation squared is variance.
Or standard deviation squared. Okay.
Yeah. And then they both just tell you how far away you are from the mean.
Yeah, the distance from the mean.
And covariance tells you how how related the data are.
Yeah, this one, those two.
Correlation, you know about correlation, right?
Yeah, but I'm not good at it.
Yeah, we'll apply it. This is the part where it gets hard, that's why. Okay.
So let's go to this one right here. Why is it 2?
Why did you say week 2? Why in the world? Go back. We looked at this one already.
Yeah, we already did this one. What happened?
Check, go back. Why
How
is
did
that?
I get here?
Why in the world?
Well,
this is still saying week 2.
is this in week 2? No. Let's move on from that week 2. Week 3. Yeah, this one. Yeah, that's one right here. Yeah, probability and randomness.
Okay, this is where it gets a little weird, right?
Yeah, this is where things start getting a lot crazy.
Yeah, there's a lot of theory with probability. It's not that bad though. Let's look at it. There's a lot of it's because it's like very highly mathematical.
Yeah, this is where things really get crazy.
Okay, I'll try my best to explain it. It's not that bad. So let's look at this. What is the probability of observing an even number? So you have a die, right? And then what's the probability of each getting a 1 to 6? What is that one? Probability. Probability is like the chances over the possible outcomes. Isn't that what it is? Probability. That like how many different events can you get from a 6-sided die? You can get a 1, right? A 2,
up to 6.
Okay, and then how many possible things can you get? 6,
5, 4, 3, 2, 1.
6, right?
Yeah.
Okay, So when it's saying suppose you roll, what is the probability of observing an even number? How many even numbers are from 1 to 6?
There are 3.
So 3 over 6, what is that?
So that's 0. No, that's 0.5.
Yeah, that's what it is, right?
Mm-hmm.
So that's what it is. That's 1/2.
That's 1/2.
Yeah. So that's how you do probability. I'll tell you, there's a lot of math. Let's go to 2. This is not that bad. Okay.
A survey of a number of large corporations gave following probability table for events related to the offering of a promotion.
Okay, what is the probability that professionals selected at random would accept the promotion? So accept would be accept, so that's 0.7435, which is what you got right there.
Yeah, but I got that from YouTube.
It's already in there, right? But do you know why? Because you have like this is called this is kind of like a frequency probability table. It gives you like, the two different things, or like many things that are correlated. Like if you have accepted and you have 2 career, and you have accepted and 1 career, and you just run through this. You run through you add them. How did they get 0.7435? How did they get that one? You add it, right? You add 0.276, 0.3145, 0.1530, right?
Yeah.
You know that one? So that makes sense?
Yeah, I just added, but
Just
not
added,
that,
right?
not that I knew what was behind it.
So that's how you got this guy, right?
Yeah.
Okay. So that's what's going on. This is how you do like this probability tables. Is you have like 2 things. You have accepted, you have this guy, or this guy. And each one of them are given. This is the probability of having it accepted and 2 career. And then this is the probability of having it accepting the promotion and having 1 career, and then unmarried and then accepted. And then when you're saying what is the probability of 2 career marriages from the data set, it's this guy, right? And this is just adding the columns. And then you add the rows, you get this guy. If you had to fill it out, that would make sense, right? If you had to fill it out. Okay. Okay, let's move on then.
All right.
So this one, what is the probability that the unmarried professional selected at random would accept the unmarried? So let's take a look at this one. Report answer as a decimal. Unmarried would accept the promotion. Selected at random. You got 0.9. The unmarried person selected would accept. So it looks like there's a guy right here, but the answer is 0.9. Why is it 0.9? So the unmarried professional would accept the 0.15. You probably have to minus, this is 100. How did you get the answer?
YouTube.
The thing with probabilities, like you have to minus like the ones that they share. So like if you were to look at this 0.9 is probably something that they had to share. Would accept the promotion. So, and let's see if the numbers. The unmarried professional. Oh, I think I know what did that. So if you did 0.1530 divided by 0.17. So you just divide it by this number. So you know what it's saying, probability that an unmarried professional. So this unmarried professional, you need to get this guy, right? This is the unmarried professional probability, right?
The 0.17.
Yeah. And then probability is always a number over something, right?
Yes.
So this 0.1530, this is the probability of the unmarried professional. So this is a part of this 0.15, 0.17. It's a part of it, right? So try to do this in your calculator. 0.1530 divided by 0.17.
Okay, let me run this one. Calculator.
You're gonna get 0.9.
So we got 0.1530.
Yeah.
0.17. Yeah. So it's point.
So you have to really read the question like carefully, because what is the probability that an unmarried professional would accept the promotion? And a probability is always a number over something, right?
Yes.
So that number is this guy, unmarried, right? Total, right? And then the other one is the accepted plus unmarried. Right? That's what that is. Unaccepted plus unmarried, which is just 0.1530 over 0.17.
So accepted plus unmarried.
Which is this guy, right? This is the probability.
That is probability.
Let me put this another way. Let me give you another perspective of this. We probably have to like stop soon. Maybe we'll stop to this one. I have like an 8 o'clock. I know it's pretty late, but I have another appointment.
Okay, got you.
So another way of looking at this is it's saying the probability of unmarried professional, right? It would be the people that the unmarried. I'll just put unmarried, accepted, or unmarried, rejected, rejected, plus unmarried, accepted, right? And then the top part would be the unmarried, accepted. That's what it's saying, right? What is the probability that the unmarried professional would accept the promotion? So he wants you to, in other words, he wants you to find the probability of unmarried accepted people over the total number of unmarried that rejected plus the unmarried plus unmarried accepted people, which is the total number, right? Does this make sense?
Okay, unmarried accepted our.
And then when you read this table, you just pretty much fill it in. So what is unmarried accepted? What's the probability of that?
So unmarried accepted, that's 0.27. No, unmarried accepted 0.1530. And then unmarried rejected is, I don't see that.
And then so unmarried rejected is this guy. You just go over here. You go through, you read it through the
Oh
table.
yeah, there we go. Oh yeah, so it's 0.0170.
So okay, you add it down here, 0.0170, right? Plus 0.1530, right?
30.
You could look at it this way as well. But the thing is, you already have the denominator, right? You already have the bottom number. You already have this guy, right? You have this guy, which is the total unmarried people, right?
Yeah.
The probability is always you need to know what population. So what is your total versus part of the total. The probability is always part of the total versus the total number. The total number in this case is the population of unmarried people. this number, the bottom number, is the total number of unmarried people, which is what it's saying, right? What is the probability of an unmarried professional? And then what is it asking? It wants the probability of the people that accepted the promotion, the top number, the unmarried people that accepted, over the total number of unmarried people in the population. Does that make sense?
Mm-hmm.
Yeah, we'll go over them more, but like, first of all, does this table make sense? Like reading this table.
What I don't understand. Okay, so when we divide this thing,
yeah,
we will be left with 1 over 0.17.
When we divide it, we get 0.9, right?
Yeah, so 1 over 0.17.
Yeah, right?
Yeah.
No, you get 0.9.
If you use this formula, then I don't know how you get to 0.9.
Yeah, it's if you look at that one, look, if you did 0. It should be the same thing. If you get 0.1530 divided by 0.017, right?
Right.
Plus 0.1530. It's 0.9, isn't it?
Okay, there we go. Yeah, got it.
This right here is this number plus this number should be 0.17, right?
Yes.
It's the same as this guy.
Okay, got you.
The bottom number is 0.17.
Okay, got you.
And then someone can ask you different things about this question. Like, what if I wanted to know, hey, I want you to tell me how you do this. I want to know what the probability is of someone that, of all the people that have one career and they're married. I want to know the probability of someone that has one career and married that rejected the promotion. What do you do?
Okay, the person that got rejected was unmarried. Rejected is 0.0170.
They have one career.
They have one career.
And then they're married.
And they are unmarried.
They're married.
And they are married.
Yeah. What is and then I want to know what the probability is of someone in the one career and they're married of them rejecting the promotion.
Then that would be 0.0555.
It wouldn't it wouldn't be that one. This is the probability of it in total. This number is this is the number of like the one career married person that rejected over the total number, over the population. I just want to know for all the people that have one career and they're married, I want to know what is the percentage, what's the probability of those guys rejecting. It's a different question. I know, like
you want to know the percentage of the people who are
who rejected out of the one career people. So like so
that would be.
So it would be this one. So you would have this guy right in the bottom, and then like you have this guy at the top. Right? You have that guy. And whatever the value is.
So you take the total divided by that one. So then my answer, let's see what you're doing here. 0.555 divided by 0.37, that'll be 1.5.
0.15, right? 0.15.
0.15.
Yeah, it should be less than 0.
Yeah.
Or less than 1 rather.
Less than 1.
Yeah. So do you understand that? How I got that?
Yeah.
So you could ask that same question. It's not the number in the table because this number is the total probability. You want the relative probability. Have you heard of those terms, total and relative? So this is the total probability. This is the probability of like the thing in the table. This one, you have to know what probability you're taking of. It's the people. This bottom number is is everything. This is that one number right here.
So that's the total population.
Yeah, but you don't. We're not asking that question. We're asking relative probability. We're saying out of the one career people or out of the unmarried people, how many accepted, how many rejected. It makes more sense if I say it that way, right?
Right.
Yeah, and that's what they're saying. That's what they're asking.
Okay, got you.
Okay, that's good. Yeah, and I actually had to explain that. Probability is like one of those things. Like I have to explain this to someone else. So they were taking their GRE. I don't know if you've heard of the GRE. And then they were asking me like, how do you do like factorials? Or like, what is combinatorics, or like what is probable, like what is relative, what is total probability? But yeah, we'll go over more of these. I like doing probability actually. It's like one of the.
Yeah, we'll go over that the rest tomorrow.
Okay, we'll do that tomorrow. So chapter 3. I wanted to finish chapter 3, but I guess it's the hardest one.
Right.
For now. Yeah, we'll cover 3 and then 4 and I think 5. We'll tomorrow.
Yeah,
we'll start off from that because we don't have to cover the coding. So I think we'll finish it tomorrow.
Okay, cool.
Okay.
All right. Thank you so much.
Have a good one, Mary. Yeah, like please let me know if there's other questions, and then yeah, I hope you pass your exam.
Okay, cool.
All right.
All right.